Hi everyone. In this question, we solve the question sort an array of zeros, ones, and twos. So we are given an array that only consists 0, 1, and 2. We have to sort this array in the assignment. So this is a simple question at the first go when we look at it. So we can what we can do first thing we can simply apply a sorting algorithm and solve this question. So what we can do, we can normally sort it and we'll return it. The array will return it. So this approach requires a time complexity that is n log n time required to sort the array, and which does not require any space. But if this would be the question, this would not be in the DSA sheet. Okay. So there is the catch. Okay. There is the catch. We have to sort this in the minimum time complexity. Okay. So if the array only consists 0, 1, and 2, then what we can do, we'll traverse the array, maintain a array of size 3, and that is particularly a hash table, and store the frequency of each of the 0, 1, and 2. So if we take example of this array, we have two zeros, one, one. The frequency of 1 is 1, frequency of 2 is 2. Then what we can do, in the array that we passed as an answer, we'll have the two zeros, then we have 1, 1, and we have two twos, and we pass this as an answer. This approach requires a time complexity of order of n and a hash table of size 3. Okay, so it requires a constant space complexity. Okay, but this is not a intuitive approach. We use a better method to solve this problem. We use a Dutch flag algorithm to solve this problem. The Dutch flag approach to solve this problem. So, so what the Dutch flag method states, we gonna use three variables, that is low, mid, and high. So what is the significance of low, mid, and high? Every element from these variable particularly denotes the index of the array. Okay, so every element from index 0 to low minus 1 will be 0. So this is the significance of low. Every element from the index 0 to low minus 1 will be 0. Okay, the mid will be used to traverse over the array. Mid is used to iterate over the array, and every element from high plus 1, that is h plus 1, you can basically say high plus 1 to n minus 1 is 2. So what is the case? Every element from 0 to l minus 1 will be 0. Every element from h plus 1 to n minus 1 will be 2, and mid is used to iterate over there. So this is the significance of the three variable we're gonna use in the algorithm. So what the algorithm states, the basic variables that we are using is low, mid, and high. If the mid is used to iterate over the array, okay. If the value present at the m, that is basically the mid index, is 0, then what we have to do, we swap the value that is present at initially, let me clarify this thing. Initially L would be at 0, H would be at n minus 1, and mid would be at 0. Okay, mid would be at 0, L would be at 0, and H would be at the last index. Okay, H would be at the last index, L would be at the starting index, and should also be at the starting index. Okay, so whenever we encountered at the mth index, we encounter the value as 0. So what we have to do, we swap it with the value present at L. Okay, and we increment L by one position, M by one position. Simple. If the value present at the mth index is 1, we simply just move M to the next position. And if the value present at the mth location is 2, we swap it with the element that is present at the H index. Okay, value present at the H index, we swap it with the value present at the M index, and we decrement H by 1. And we iterate over the array until M is less than H. Okay, until M is less than H, we're gonna perform these three operations. So let me do a try run over a test case. At the starting, M would be at 0, L would be at 0, H is at n minus 1, that is the ending index. The current element to which the M point is 0. So we have this condition. So we'll swap the value present at the Lth and the Mth index. We swap it. So these both point to the same location. Na? So we swap these both. Okay. So we move to the next position. M would be at the next position because we have it incremented by 1, and L would be at next position. Now again we check. Again the condition would be check if M is less than H. Yes, it is. Then we check the value present at the mth index. The value is 2. Now the condition would be satisfied is this one. We swap the value present at the H and the mth index. So we swap these two values. So the current condition of the array would be this, and we have 2 here, and we decrement H by 1. So H would be at, so this is the array, and now our H would be at this position. M would be at this position. Sorry, we do not have to increment M now. We just have to. Oh, sorry. So we just have to decrement H. That is what in the algorithm, and M would be at the same position as before. M would be here. L would be also. Again the loop will, again the condition for the loop will be check if M is less than H. Yes, it is. We again check the value present at the mth index is 0. We swap it with the value present at the L, so they both point to the same index. So we move M to the next position and L to the next position. Simple. Again the value, we check the value for the loop, the condition for the loop. M is less than H. Then again we check the value present at the mth index. It is 1. We increment M by 1. Okay. We again check the looping condition. Is M less than H? No, it does not. Our loop will be over. Now we check the significance of L, M, and H. Is the value. So one more thing. If this loop will run till M is less than equals to H. Okay, not less than X, less than H. It will run till M is less than equals to H. Okay, so again we check. So here the condition of the loop will not terminate. Loop will not terminate. We again check the value present at the mth position. It is 2. We swap the value. It would be same. We decrement H by 1. So H would be here. M would be here. Now the significance would be true. So every element from 0 to L minus 1. So the current condition of the array and the pointers are, we have 0, 0, 1, 2, 2. L is here, H is here and M is here. Okay, so all the elements from 0 to L minus 1 are 0. Is it so? 0 to L minus 1 are 0. Yes, they are. All the elements from H plus 1 to N minus 1 are 2. H plus 1, that is from this index to the end of the array. Yes, they are 2. So the significance is true. This is the method to solve this particular problem, that is 0, 1 and 2. This method is called Dutch flag method. It requires a time complexity of order of n at max and require a minimum number of comparisons. Okay, we don't have to use any space. Okay, space complexity is constant. So this is a better method to solve this problem. So this problem is asked in the interviews. So prepare it well. And if you have any doubt, please feel free to ask. And the question link and the solution, the code for this will also be available in the description. Okay, bye.